rational function is defined by a quotient of polynomial and has the form f of x equal to pq over p of x over q of x, where q of x cannot be equal to 0. The domain of a rational function includes all real numbers except those that makes q of x, what we have in the bottom of the fraction, that is the denominator, equal to 0. So let's take a look at examples to make sense of all these definitions here. We want to give the domain of each rational function using set builder notation and interval notation. So here we have f of x is given to me as x plus 6 over x squared minus x minus 6. So remember, we don't want what we have at the bottom of the fraction, x squared minus x minus 6, be equal to 0. If that happens, then this whole thing would be undefined. Values of x that makes the denominator 0 must be excluded from the domain. To find these values, set the denominator equal to 0. So what we do is we look at the denominator only. We don't care about the top of the fraction, just the bottom. We take x squared minus x minus 6 equal to 0, and we find for what value of x that would become 0. To do that, we need to factor this. We already know how to factor. X plus 2 times x minus 3. If I solve for this, I would get x equal to minus 2, x equal to 3. So these are the two values that we do not want to have. So to find the domain would be value of x such that, x is all real number except x cannot be equal to negative 2 and 3. So it could be any number we want except those. So if you look at the number line, you can see that maybe more clearly. So if I look at my number line, let's locate those numbers. If this is 0, negative 2 would be right here. We don't want that x equals to negative 2. We don't want x equal to 3. These are the values we found. So the solutions would be all the number from a negative infinity, could be any number from negative infinity all the way to here, right? So if I write this in interval notation, it would be negative infinity, comma, negative 2. I'm going to use parentheses because I don't want to include negative 2. If I use brackets, then I have to include that. Okay, but the rest of the solution would be from negative 2, go all the way to 3. This would be the solutions again. So I'm going to put union. I'm going to use parentheses again, all the number from negative 2, comma 3. Again, parentheses, I'm not going to include 3. Finally, I'm going to include all the numbers to the right of 3, because all the numbers are included right there. So the little arrows here. And then union. So it would be, again, parentheses, then with positive 3, or just 3, comma, infinity, or positive infinity. This would be my interval notation. Shows the domain. That means we're including all the number except these 2 points. So if I would say for what value of x, f of x would be undefined, what would be your answer? You would say if x equal to minus 2 or x equal to 3, then this expression would be undefined. If I ask for what value of x, f of x would be equal to 0, then what would be your answer? For what value of x, f of x would be equal to 0? In order for f of x to be equal to 0, f of x would be equal to 0 when what we have at the top of the fraction is equal to 0, right? Not at the bottom anymore. When x plus 6 is equal to 0. Okay, if I solve for this, x would be equal to what? -6. So if x equal to -6, f of x would be equal to 0. Because -6 plus 6 would be 0. 0 over anything here would be 0, assuming that this doesn't come out to 0. It doesn't. If I put 0 here, that becomes -6. So it would be 0 over -6. So f of x would be equal to 0 when what we have at the top of the fraction would be equal to 0. F of x would be undefined when what we have at the bottom of the fraction is equal to 0. It would be these two points. Give the domain of each rational function using set builder notation and interval notation. Here it is. F of x equal to 3 plus 2x over 5. In other words, for what value of x, the f of x would be undefined. Okay, those of you watching this live with me, can somebody tell me for what value of x this would be undefined? Do I have any x at the bottom of the fraction? No. So the denominator is 5, so it cannot ever be 0. So the domain would be all real numbers. There's no restriction there. The only time you have a restriction is if you have the x down here. So if there's no x down at the bottom of the fraction, the domain would be all real numbers. That's how you can note all real numbers, from -infinity to +infinity if you want to write in the interval notation. Now, if I want to know for what value of x this expression is equal to 0, then I would let 3 plus 2x equal to 0 and then solve for x. But we're talking about domain, means for what value of x this becomes undefined.